Welcome back. We're looking at chapter 9, and this is part 3 of the part 3 video. When we last left off, we were going to jump into pointers as function parameters. I know that you were just sitting there going, man, if only I could pass pointers to functions. Well, here is how you do this. It's going to look similar to what we've done in the past when we were talking about using the address as the argument to the function. But let's just jump in, take a look at it. So a pointer can be used as a parameter. It works like a reference variable, which allows us to change what's in the variable or the contents of the variable within the function. So remember before we had where we were sending parameters, and if you made a change to that parameter in the function, it didn't change it back in the calling method because we had gotten a copy of the parameter. And then we showed a way that we could pass by reference. Well, again, this is another way to pass by reference. And so when we make changes to the variable in the function, you're going to see that it actually changes the contents of that variable up in the calling method as well. So it does require the asterisk on the parameter in the prototype in heading. So as you can see, we got this avoid get num int with a, and the way I like to read this, by the way, is we've got a variable pointer that points to an int, right? So a pointer, so the named pointer, that is a pointer that points back to int. Now, again, we're making it a little difficult because the variable name is pointer as well. If this was something else, let's say var, then I would be saying var is the name of a variable that points to an int. But in this case, we're saying pointer is the name of a variable that points back to an int. And if we use the asterisk in the body to dereference the pointer, we would get what's in the value. We get what the pointer is pointing to. And then address is an argument to the function. So as we can see that we're passing in this pointer, we have get num, and we're going to pass in the address of the of where the num variable is pointing to. So here's an example. We've got this method swap, and it's looking for a pointer to an x and a pointer to a it's looking for a pointer to an int called x. We're going to call it x, and a pointer to an int that we're going to call y. And we're going to take these variables, and whatever's in y, or the contents of y, we're going to put into the contents of x. And then whatever is in temp, which was what was in the contents of x, we're now going to put into the contents of y. Now, why does temp not have the star? Because we set this up as just a standard int, and so we didn't need to do that because when we call temp by itself, it's going to give us the contents of temp anyways. And so we're going to take what's the contents of temp and store that into the contents of y. So now when we have int n1 equals 2 and num2, int num1 equals 2 and num2 equals -3, when we do the swap, now num2 will be 2 and num1 will be -3. I'll let you take a look at this program to see some different uses of the int pointer, and it's very much like what we've been talking about. And we can't have pointers to constants. So we've talked about constants in the past. This is where we want to set something like a literal, maybe a number, up that can't be changed. Once it's set, it's done for you. And oftentimes we put those variables in all caps. So let's say, for example, we need to make use of pi, 3.14. We would set up a constant, probably called pi, all in capital letters, equals 3.14, or 22 divided by 7. And we would then make use of that, and we can't change it. We can make sure that by doing that, we make sure our program can't mess up what pi is anywhere else in the program because we made it a constant. Well, we can do the same thing with a pointer to a constant. So here is an example of where we are going to make a constant array of doubles that's the size of 6. Here's our 6 values. And because we've made this a constant, now that we've went ahead and declared the values, we cannot change it either. And again, most of the time, this would be in all caps. So now we have in this code, we've got pay rates, which is an array of constant doubles. We have pointer to constants. Suppose we wish to pass the pay rate array to a function. Here's an example how we could do that. And the fact is we are, once again, because we're saying constant on here, we're making sure that nothing changes it. And we're using the dereferencing star there, so that way when the address comes in, we know to use it use the item at the location in memory, which again doesn't matter because it's not like we can change it in this function. So the declaration of a pointer constant, we are well aware that obviously you have to have this constant. And then beyond that, it's pretty standard to what we've been doing before, which is we have a variable name rates, which is a pointer to a double. Constant pointer is a pointer that is initialized with an address and cannot point to anything else. That makes sense. So once we've set the where it's pointing to, it cannot change. Constant pointers. So in this example, we now have where we are saying that this pointer is going to be a constant pointing to an int. Now, what does that mean? That means that the address that we have that we're pointing to can't change. And then we also have a constant pointers to constants. So before we had a pointer to a constant, then we had a constant pointer, and then now we have a constant pointer to a constant. So like with the other ones, we just combine them. So now we have this variable named pointer that's pointing constantly to the same area. That's also a constant int. So what does this mean? It means you can't change what the content is, and you can't change where it's pointing to. And we just talked about this, again, just to understand a little more clearly, because we have constant here between the star and the variable name, it means that this pointer will not be able to change to a different address, to look at a different address. And because we're declaring the constant in out here, it means the contents of where this pointer is pointing to cannot change either. I think that's a great place to stop for this video. Again, kind of go back through that. We talked about constant. We then talked about pointers to a constant. And then we talked about constant pointers. And then we talked about constant pointers that point to a constant. Quite a bunch of constants in there, so I'll give you a moment to digest all that. Again, this is a great place to go to your online C++ compiler and try a few things. Try to see if you can change a constant, the contents of a constant pointer. We'll see you soon, and we'll jump into 9.8.